Hello everyone. As we know, the lake ecosystems and the organisms that live within them are vulnerable to temperature change, including the increased occurrence of thermal extremes. However, very little is known about the lake heat waves, periods of extreme warm lake surface water temperature, and how they may change under global warming, and how they affect on plankton communities. Therefore, we conducted the experiment, which name is Means and Extremes Effects of Climate Warming Scenarios on Plankton Communities. This experiment was conducted at Balaton Limnological Institute at Tihany, Hungary during last summer. At the beginning, I want to go brief of the extreme climatic event that is produced from the chain of indicators of temperature or precipitation. As an example, a second-breaking heat wave of 3 to 4 days took place in Western Europe in last year, with temperature exceeding 40 degrees in many countries. Heat waves pose a substantial risk to human health and ecosystems. There are many consequences of climate change on the aquatic ecosystem, specifically loss of biodiversity or increased eutrophication. Take an example of phytoplankton blooms at the Atlantic that was taken by Landsat-8 satellite. The blooms were likely caused by coastal upwelling, and that killed a lot of marine species. And the scenarios of ocean biodiversity in warmer conditions. If the temperature increases 1.5 to 2 degrees, there is only 1% of coral reef remaining. Global change in the lake temperature over past 25 years were shown in the left picture. Red shades indicate warming and blue shades indicate cooling. The study found the Earth lake warming about 0.61 degrees. You can see on the map there are a lot of red points around the world nowadays. And the right picture show historical and future projection of the intensity and duration of the lake heat waves. The temperature and spatial pattern in average intensity are shown in the picture A, B, C, and duration shown at the picture D, E, F. Picture A and D show the lake heatwave under the climate change that will lead to many effects on the ecosystem. This is a main reason we conducted this experiment. With the aims of the study, we want to get to know does increased water temperature result in the change in the zooplankton community compositions and the top-down control of phytoplankton. Will heat waves have a more intense and rapid effect on the zooplankton communities compared to a constant plus 3 degree increase in the temperature? We took the sample from Lake Balaton, which is well known as one of the biggest fresh shallow lakes in Europe. In general, Balaton Lake is rich in mineral turpentine. At the Tihany Peninsula, we set up an outdoor mesocosm facility. This picture shows how we set up our mesocosm. The experiment was carried out in 12 mesocosms in the outdoor mesocosm facility. We randomly assigned 4 replicates to control constant plus 3 degree increase and a 1-week heat wave of plus 6 degrees. Each mesocosm was filled with 3,000 liters of water from Lake Balaton, and in each mesocosm, we set up a physical-chemical sensor and air pump. Continuous measurements of basic physical-chemical parameters, including pH, temperature, dissolved oxygen, conductivity. We took daily measurement of algae biomass with a handheld field fluoride method used for measuring chlorophyll excitation. We call it aquapan, and zooplankton samples were taken twice a week for the first month and the additional sample of after 2 months. Increased temperature in both scenarios were elevated and kept in level as compared to the actual means of 4 mesocosm based on the continuous temperature measurement. Heat waves took place in the first and the third week of experiment. After 4 weeks, we just observed how the community recovered without treatment application. This slide shows the pattern of chlorophyll and fire. At the beginning, all mesocosms had the same energy input. In the first heatwave occasion, the chlorophyll and fire of heatwave mesocosm were not high as compared with the constant mesocosm, but after that, the algae developed rapidly. As a consequence, the algae biomass of heatwave mesocosm were higher, and it clearly showed in the picture that we took after the first heatwave. Water in controlled mesocosm was more transparency compared with the water in the heatwave mesocosm. The second result that we want to mention is the zooplankton abundance. Let's have a look at the chains of the main group include Copepoda, Gladocera, Rotifera, and Voliture. The total of Copepoda has increased in 3 kinds of treatment. It seems like Copepoda had adapted with the treatment. Inversely, the Voliture showed they again the treatment application. The total of Voliture species decreased after the treatment. Now we will move to more detail of some significant results on the abundant rotifer Polyatra species. This species declined in the heatwave treatment. It can be either a direct effect of heatwave or either increased the predation by copepod, driven by higher metabolism at high temperature, and the reduced number of rotifer could contribute to the algae bloom as grazing pressure of algae decreased. The last result is the zooplankton community composition. During the experiment, we analyzed total 6 occasions. We will have a 6 sample days. In general, there are a bit different among 6 occasions. On the third occasion, it seems all mesocosms stay close together because basically they were from the same community at beginning. In the end, we have a much bigger circle. The mesocosms move a little bit far away from each other. The Bermanova show the p-value that significant difference between the day and between the treatments. More specific, at the first and the second sampling, the 3 treatments were overlapped together. There is no significant difference according to the treatments, so the treatment did not affect on community. But at the third and the fourth sample day, the heatwave with the red color and the control with the blue color are a little bit more far away each other. This significant result may be related to decreased Polyatra species. These were the only species with significant treatment-specific abundance difference. At the end, when we stop the treatment, all the treatment overlap together. In conclusion, this experiment proved that increased water temperature can contribute to increase the phytoplankton biomass. It also affects on zooplankton abundance and influences the community composition. Heat waves have a more intense and rapid effect on zooplankton community compared to the constant increase in temperature. That's all my presentation. Thanks for listening.